So good morning, everyone. Today we will start the unit 2, where we are going to discuss about the transient response analysis. Transient and also along with the steady state analysis also with respect to different independent and the dependent sources. So here the transient response analysis of which kind of networks. So we are going to discuss about the transient behavior of typical RL, series RL, series RC, and series RLC circuits with respect to different sources. That means we are going to discuss about the transient response or the transient analysis with of a RL circuit and RC circuits with the DC excitation, transient response analysis of RL, RC series circuits with sinusoidal excitation. Right? So we are going to discuss about these different things. For this one, the basic prerequisite for learning this unit is the differential equations. The concept of differential equations is going to play a very important role in analyzing the transient behavior of the RL and RC circuits. So that means which type of differential equations? So it can be a linear differential equations. So that means which are in the form of, we are going to have the first order differential equations, second order differential equations. So with respect to first order and second order differential equations, we are going to analyze the transient behavior of the series RL and series RC circuits. So I request you all to go through the basics of your mathematics differential equations, because we are going to use the differential equation approach for getting the transient response of series RL and RC circuits with respect to different sources. Right? So now before going to the getting the equations or derivations of this transient behavior of the RL and RC circuits, so let us discuss what do you mean by this transient response. So where it comes from, right? So let us go through this. So for this, so in this lecture, we are going to learn about what do you mean by time response. That means, so which is nothing but the steady state response and also the transient response. As we are going to deal with the transient behavior of RL and RC circuits, we are going to estimate the initial conditions of different energy storage elements. So what are the energy storage elements here? If I speak with respect to the RL circuit, the energy storage element is going to be the inductor. If I speak with respect to the RC circuit, the energy storage element is going to be your capacitor. So the resistor won't come here, right? Why? Because the resistor is having the capability of tolerating different types of voltages and different alterations in the voltages or current, right? Now, what do you mean by time response? If the output, the time response is nothing but, if we speak with respect to the time response, if you consider an electric circuit, the output of the electrical circuit or the response of that electrical circuit or a network is going to vary with respect to the time. It is nothing but the time response. Then we can say it is nothing but the time response. The response of an electrical circuit for a given input signal or for a given input, if it is varies with respect to the time, then that type of response is nothing but the time response. So this time response is going to have two types. One is, that means we can analyze this time response by dividing into two types. One is the transient response and the other one is the steady state response, right? So one is the transient response and the other one is the steady state response. So what is mean by transient analysis? The simple definition, if you want to say about what you mean by transient analysis, it is nothing but the study of the behavior of a circuit or a network when it is subjected to change or disturbance. When it is subjected to change or disturbance is nothing but the transient analysis. Or we can say it is nothing but the transient behavior, right? So if we first let us speak with respect to the general examples for the transient. So general examples, if you want to say, we can consider the behavior of a student when the transition is going to take place from one class to the other. So general, literal example, these are the literal examples. The transient behavior of a student when the transition takes place from one class to the other. And the other one best application is nothing but the ceiling fan, right? So if we switch on till the switch is on, the ceiling fan is going to be in the steady state or in the static mode. If you switch on there, then it is going to move into the transition mode, right? So this is nothing but the transient. That means it is changing its state. It is changing its state from due to the alteration or due to the change or some disturbance is nothing but the transient analysis. So in a network, if we can, let us consider in a network, if you consider an electrical network or if we consider a circuit, so why this transient is going to be happen? Why this transient is going to take place? So the transients in the system is going to occur due to the presence of the energy storage elements. Due to the presence of the energy storage elements. So what are the energy storage elements in our context? So the energy storage elements are here the inductor and the capacitor. Inductor and the with respect to the RLC circuits, the energy storage elements are the inductor and the capacitor. So one more point which you have to remember here is, so the energy stored in an energy storage elements like inductor and the capacitor cannot change instantaneously, cannot change instantaneously. And also it is going to oppose the sudden change in the system behavior, which is going to results in the oscillations, right? Which is going to results in the oscillations, right? So this is going to replicate the instability of your RLC circuits, right? So what are those, how, which is going to oppose which parameter? So coming to the inductor, it is going to oppose the sudden change in the current due to its electrical inertia following the Faraday's laws of electromagnetic induction. Whereas the capacitor is going to oppose the sudden change in the voltage. So that means the energy stored in a capacitor is going to be same in the next cycle or within the next moment. The energy stored is now doesn't going to change its behavior, right? So now coming to this transient behavior, if we consider if a circuit which is changed from one state to the another, if we say it is in transient state, so the time taken for the circuit to change its state from one state to the another state is nothing but your transient time. So we can use any kind of algebraic or KCL or KVL equations to analyze this transient behavior of any kind of electrical circuits, right? So now, if we speak with respect to the steady state behavior or steady state response, what do you mean by steady state response? So we can say a circuit is going to be, if it is having a constant source, is going to be in steady state if the currents and the voltages do not change with time. So thus the circuits with currents and voltages having constant amplitude and frequencies is going to be same, right? So that means here, if we consider, let us consider an example of a transient behavior. So let us consider a sinusoidal signal as shown in this figure. So here the response, let us say this is the output response of your electrical network. So if we consider, instead of sinusoidal, we can consider a pulse also, no issues. Anything you consider, no problem. But here you can see here, so this is the state, initial state, and it is switching from one state to the another state, right? And here, so this states, the states which is going to be switching, the starting and the last state, these particular states, you can say these states are nothing but your steady states. So when this circuit response is changing from this state, or if you consider a pulse signal, when it is changing from one state to the another state, let us say this is the high state and this is the low state. So when the circuit is switching from the high state to the low state, so we are going to have the short spell of time over here. The short spell of time which is required to switch the state of the or the response of the circuit from one state to the another state is nothing but, the short spell of time is nothing but your transient time. Transient time. So these are nothing but, that means from one steady state to the another steady state, the switching reaction is going to take place from one steady state to the another steady state, and it's going to remain for some time. And these particular states are nothing but the steady state, and the behavior of the circuit at this particular states is nothing but your steady state behavior. Nothing but your steady state behavior. That means at this instant, the circuit elements or the sources or any kind of internal circuit elements is doesn't going to vary. That is the reason why the circuit, the response is going to be in the steady state over here. Whereas here you can see when it is altering from one state to the another state means the circuit behavior is going to get the circuit, some circuit elements are the source, the input signal or something is going to be varying with respect to the time. So that is the reason why this transience is going to get happen. This particular time or this particular states is nothing but your transient behavior of your circuit. So how the circuit is going to behave in the, this energy storage elements is going to behave in the steady state. So the inductor, you can say, if the independent source is connected to the electrical circuit or a network having one or more inductors and resistors, we say, so then the electrical circuit or network is going to be in steady state because we have connected independent source. So therefore, the energy stored in the inductor of the electric circuit is going to be maximum and constant here. Why here? Why it is constant over here? Why it is going to be constant? Because it is a independent source. That is the reason why the energy stored elements in the energy stored in the inductor is going to be maximum and constant, because it is in the steady state. So mathematically, we can see this one, the energy stored, we can represent it as WL is equal to Li square by 2. Or we can say the very popular equation that is nothing but half Li square. Half Li square. Half Li square. Where this IL is nothing but the constant. So that is the reason why this inductor is going to act as a constant current source in the steady state. Constant current source in the steady state. So let us look what is going to be happen to the capacitor in the steady state. And simply we can say the one more statement we can make it, the voltage across the inductor, we can say it is nothing but VL is equal to L di by dt. So if this is the constant, the IL is constant over here, that means this VL is going to be 0 in the steady state. So that is the reason why the inductor is going to act as a short circuit. If there is no voltage is 0, that means it is nothing but the short circuit, and the same is going to be applicable in the steady state. The inductor is going to act as a short circuit in the steady state. So coming to the capacitor, what is going to happen with respect to the capacitor? So if the independent source is connected to the electrical circuit, or if we consider the same thing with having a capacitor and resistor here, that means it is nothing but the RC circuit. So then that electrical circuit or a network is going to be in steady state because we have connected a independent source. So that means the energy stored in the capacitor of that particular RC circuit is going to be maximum on constant value. So if you want to represent the same thing in mathematically, where we are having the energy stored in the capacitor, we know that, which is nothing but half CV square, half CV square, right? Here I have mentioned here half CVC square. That means VC is nothing but the voltage drop of the capacitor, right? Voltage drop of the capacitor. So that means, so VC is the maximum and constant. This is the maximum and the constant value here. So the capacitor is going to act as a constant voltage source in the steady state. Constant voltage source in the steady state. Is it clear? So now, if we go to the next slide. So the same thing, if you want to write, the current flowing through the capacitor is going to be, what is the current flowing through the capacitor is going to be here? IC is equal to, we are having C dVc by dt. So if we say that from this equation, WC is equal to CV square by 2, if we say VC is the constant value over here, that means here the IC is going to be equal to 0 amperes, the initial conditions. So that means at the steady state, so the capacitor is going to act as a open circuit. If current is equal to 0 means that means it is nothing but a open circuit. The element is nothing but open circuit. There is no use of the element. That is the reason why in the initial stages, the capacitor is going to be, initial condition, the capacitor is going to act as an open circuit in the steady state, right? Thank you. So in the next lecture, we are going to discuss about we are going to derive the expressions for the transient response or the transient current of the series RL circuit and the RC circuit with DC excitation. That means the DC response we are going to look into with respect to the transient behavior of RL and RC circuits, right?